In this chapter, we're going to be working with radicals. In this section, we will focus on taking roots and finding the domain of a radical function. At this point, we are more than likely comfortable taking the square roots of numbers and the cube roots of numbers. If we are square rooting, we are looking for one of two same numbers that multiply for the radicand. And the radicand is the number under the radical. With cube root, you're looking for one of three same numbers that multiply for the radicand. Notice how the square root of a negative is not possible, or rather what we state is non-real, since we cannot come up with two real numbers that will multiply for negative 16. But with cube roots, the cube root of a negative is a negative, since, like in that last example, negative 4 times itself 3 times gives us negative 64. When we're asked to find the nth root of a to the n, we need to carefully read the title, since when we use the radical symbol with the even root, you need to make sure you are stating the principal root. The principal root is the positive root. If the author says the variables represent any real number, absolute value may be necessary. If the author says variables represent positive real numbers, absolute value is not necessary with your result. This absolute value consideration is only necessary with even roots. Since the title is that variables represent any real number, absolute value may be needed. It is only necessary if the result can be negative for any given value substituted in for the variable. The absolute value is necessary on the first problem. The second deals with odd root, therefore absolute value is not and is never necessary. And on the third, we place the absolute value around the variable only. The last is an odd root, therefore no absolute value. Here we redo these problems with the title being that the variables represent any non-negative numbers, so therefore no absolute value are necessary. So what we find is important to carefully read those titles. Last, we discuss the domain of a radical function. Since we are dealing with functions, we will have our radicals set to f of x or y. And since we are dealing with functions, our output must be real. Therefore, when we work with even root functions, we need to make sure our input will result in output that is only real numbers. The easiest way to figure out the domain of an even root function is to take the radicand and set it to greater than or equal to 0. Keep in mind that we cannot square root negatives. We can only square root positives or 0. The result of this will need to be stated in interval notation as you see here. Since we can take the odd root of negative numbers, we don't have any issues with any numbers placed in for x with the odd root functions. The radicand can be anything, therefore the domain is all real numbers. Hopefully this has been helpful. Thank you.